For problem 33, it reads, parallelogram ABCD with dimensions in inches is shown in the diagram below. What is the area of the parallelogram in square inches? So if you know that the area of a parallelogram is equal to its base times its height, then you can solve this very easily. You know that the base is equal to, and be careful here, you have a segment that measures 5 and then a segment that measures 15. So the entire base is equal to 5 plus 15, which is equal to 20. And then you would multiply that by its height, which is this one right here, of 12. Don't be confused by this 13. That's not the height of the parallelogram. That's just the measurement of one of the sides. Anyways, 20 times 12 is equal to 240. Everything is in inches, so we don't have to convert anything, and this would give us 240 inches squared for its area, which is choice D. But if you don't remember the area of a parallelogram, you shouldn't panic. There's a couple of things that you can do. Watch. You could realize that at the end of the day, you have this setup. This also measures 12, this measures 5, and this measures 13. So what you can do is you can say, well, given these measurements, this of course measures 15 as well. Given these measurements, I know that I have, on the one hand, this rectangle over here. You know how to find the area of a rectangle. The area of a rectangle is simply the multiplication of their sides. So in this case, it's 12 times 15. And so we're going to get, in that case, 12 times 15, which is equal to 180. So we have 180 inches squared, but that's just for this rectangular portion right here. We still need to account for triangle 1 and triangle 2. But notice that these triangles are exactly symmetrical. So we have the first triangle here that measures 5 by 12, and this happens to measure 13. I really don't need to know that. And the second triangle measures the exact same thing, 5 by 12, and this is also 13. What does that tell you? You can put these together and create a rectangle. So you have another rectangle that measures 5 by 12. So if you multiply the area of that second rectangle, let's call it R2, so you're multiplying 12 times 5, which is equal to 60 inches squared. Now you've accounted for all areas. And if you add 180 plus 60, you're going to end up with 240 inches squared, which is, again, choice D. Or you could have found the area of each of these triangles. So assuming you know that the area of a triangle is equal to its base times its height divided by 2, then you know that it would be 5 times 12 divided by 2, in other words 60 divided by 2, in other words 30, in this case inches squared. So that would be for each triangle, so you would need to double that because the other triangle has the exact same measurements. So you would get another 30 inches squared. So 30 plus 30 is 60 inches squared, which is, yes, the same area we found for that rectangle. So we would just need to add, in that case, the 180 inches squared from the rectangle, and it would give us the, again, same answer of 240 inches squared. So there were 3 ways of solving this. You either know the area of a parallelogram. If you don't remember it, don't panic. You could still figure out. Problem 33, to find the area of the parallelogram. One of the things that we could do is simply key in 15 plus 5, so we would do 15 plus 5, and then be careful that we don't do times 12 at that point. That would be an incorrect way of keying in your formula, because remember PEMDAS, order of operations, the calculator is going to do 5 times 12 first and then add 15, and that's not what we want. I'm going to clear that. We want to add, so use a parentheses, the base, which is 15 plus 5, close parentheses. That's going to be 20, of course, we know that, and then times 12. Or again, we could have just done 20 times 12 for 240. Now, we talked about other options. You could have done 15 times 12 for that center rectangle, leaving you with 2 triangles that measure 12 by 5. And again, you could have done the triangle formula, which is parentheses base times height, and then divided by 2. So it would be 30, but because you have 2 of them, it's a total of 60 plus the 180 we had before from that center rectangle, the same 240. Finally, you could have seen that you end up with two rectangles, a 15 by 12, so 15 by 12, so that's 180. We put that for a side, on the side for a minute, and then we have another rectangle that measures 12 by 5. So the 12 by 5 is 60, and if you add 180 plus 60, you again get the same 240. For problem 34 reads, if b equals a plus 3, then parentheses a minus b to the fourth power equals. Be very careful with this one, please. Let me show you some of the common mistakes. First of all, b equals a plus 3. Now they want us to evaluate the expression parentheses a minus b, close parentheses, raise that to the fourth power. What's this equal to? Well, given the fact that b equals a plus 3, we can plug in for b on the second equation. We can replace this b right here with a plus 3, because that's what the first expression says b is equal to. So that leads to, notice how I'm going to plug this in. Big parentheses. Then a inside minus, now I have to open a new parenthesis set because b is the sum of two terms, a plus 3. So I need to do this. And then I close that smaller set and then close the big set and then raise that to the fourth power. So this is the correct way of plugging in. One of the common mistakes students make is they do this. Parentheses, a minus, and they see, oh, a plus 3, and they write a plus 3 like this. And this is wrong. We're going to see why in a second. Let's go back to the correct method. We need to simplify this expression before we can move forward. Well, remember the order of operations, PEMDAS, we need to solve parentheses first. So we can't really tackle the big parentheses before we tackle, say, the smaller one right here. Now, inside the parentheses, a plus 3, there's really nothing we can do. It's a plus 3. However, we can eliminate these parentheses, but we need to take note of the fact that we're subtracting everything that is inside that set. So this is the correct way of doing that. We say big parentheses, a. Now, when you subtract a positive a, you're subtracting a. But when you subtract and adding 3 here inside, you're considering the fact that you're distributing that subtraction operation inside all of the terms inside that parenthesis set. When you subtract and adding 3, you're subtracting 3 as well. Now you close that big parenthesis and raise that to the fourth power. Notice what happens on the incorrect method that most students, it's one of the most common mistakes that students make right here. You end up with a different operation here, adding 3 as opposed to the actual subtracting 3 that you need to get. And if you don't know why, again, it's because we're subtracting the value b. So we're subtracting the entire b value, which we replace with a plus 3. That means that we need to subtract both the first term and the second term. And given the fact that you're adding that second term, when you subtract an adding element, you're really subtracting. Okay, so we can now erase this incorrect method. We're left with this expression. Let me write it again. Parentheses, a minus 3 raised to the fourth power. And we're trying to figure out what this is equal to. Well, now we simplify the inside of this parenthesis set before we do the power. Remember PEMDAS, P, parentheses are grouping symbols, then we do exponents. Okay, so a minus a, of course, that's 0. So you get parentheses 0 minus 3, close parentheses to the fourth power. Now 0 minus 3 is, of course, equal to parentheses negative 3 raised to the fourth power. What is this equal to? So here you have to be very careful. When you key this into the calculator, into your TI, make sure that you actually open a parentheses, key in negative 3, close the parentheses, and then after the parentheses, you would key in the power. Otherwise, you would end up with an incorrect answer, not because the calculator is wrong, but because you would be asking the calculator for the wrong computation. Now, negative 3 to the fourth power, you should know that this simply means negative 3 times negative 3 times negative 3 times negative 3. And if you know how to work with signs, you'll realize that negative times a negative is a positive, times a negative is a negative. But then times a negative here, the final negative sign, is a positive. So we you should be able to know that this is going to give you a positive answer. So right there, when you go back to your options here, F, G, H, J, and K, you should know that H, J, and K are automatically incorrect, simply because your answer is going to be positive. Now, we just need to know if it's 81 or 27, so you would multiply 3 times 3 times 3 times 3, and of course that's not 27, that is 81, which is choice F. But we'll see how to key this into the TI in a second so that Problem 34, we want to plug in, or rather, plug in a -3 to the 4th power. Careful how you do this. If on a TI you do -3 and then raised to the 4th power and expect to get the right answer there, you do get an answer, and this is correct based on this prompt, but it's not what you were asked to do. Remember, on problem 34, you ended up with a parentheses, -3, and then close parentheses, -3, then close parentheses raised to the 4th power. You see, if you don't use parentheses, like this first line I entered, if you don't use parentheses, you get the incorrect answer because you're actually asking the calculator for something else. Look what happens when you do it the right way. Parentheses -3 inside, and then the power outside of the parentheses. You get a positive 81. Why? What happened? Well, the calculator is correctly doing a -3 times itself 4 times. So a negative times a negative is a positive, times a negative is a negative, and then times a negative again becomes positive, positive 81. In this first scenario, the calculator actually did 3 to the 4th power and did not consider that negative sign. So it computed 81. But then, considering the negative sign, negative 81. But again, in this case, it wasn't what you were after. So be careful. Be very careful. Another incorrect way of doing this is parentheses -3 and then the raised to the 4th power inside of the parentheses. Again, it's just going to be -81 for the same reason that the first one was -81. So remember, negative values raised to some power. If that's what you want to do, always put the negative inside of parentheses, and then outside of the parentheses, raise the entire parentheses to whatever power you have. For problem 35, it reads, a park has a shape and dimensions in miles given below. The park office is located halfway between point A and point D. Which of the following is the location of the park office from point A? Note, the park's borders run east-west or north-south. So we have point A right here, point D right here. Halfway between those 2 points, somewhere around here, is the office. And they want to know the location of that park office from point A. So A is going to be your starting point. So essentially what we have to do is we have to figure out the measurement of this rectangle. Because if we know the measurement of this rectangle, then we know that its diagonal right here, halfway, is where the office is going to be located. And that means that if we're starting at point A, we would need to walk half of the distance between A and this point to the east, and then south, half of the distance between this point and D, which is a measurement of this side right here. And so we need to know the measurement of this rectangle. So let me redraw it. This is point A, and this is point D. And the office is halfway, which is here. So it's this diagonal over here. All right, so how do we find the measurement of that rectangle? Easy. FE measures 9, so that means that this side measures 9 as well. Then BC measures 8, so that means that this side measures 8. So that's all we need to know. Now, because we want to go halfway, starting on A, so if we're going to walk to the east, half of 9, that means walking east 4.5 miles. And then, once we stop there, we still have to travel south, half the distance between this segment, which is half of 8, which is 4. So you would walk south 4 miles. So notice that walking, starting on point A, walking 4.5 miles east and then 4 miles south will land you halfway between A and D, which is where the office is located. So scanning your choices, you can see that choice B is correct. 4.5 miles east and 4 miles south. Notice that C is incorrect because it's asking you to walk 4 miles east, which is not the 4.5 that we need to travel. So you would actually end up walking a little bit less, and then south 4.5 miles, which would put you somewhere here, not the location of the office. So be careful with that. Problem 36 reads, the larger of two numbers exceeds 3 times the smaller number by 4. The sum of twice the larger number and 4 times the smaller number is 58. If x is a smaller number, which equation below determines the correct value of x? So this is a very confusing prompt. The wording can very easily confuse you. So this is how I would tackle this prompt. First of all, I know that there's a smaller number. And then there's a larger number. Now, they're telling me that if x is a smaller number, x, I should start by doing that. And using, to define the larger number, I'm going to use x in terms of define the larger number in terms of the smaller number. So let's see if we can wrap our heads around this prompt. The larger of two numbers exceeds, so they're talking about this one, the larger number exceeds 3 times the smaller number by 4. In other words, if I were to multiply the smaller number times 3 times the smaller number, then the larger number is going to exceed that by 4. In other words, this larger number is equal to 3 times the smaller number plus 4. Think about it. The larger of two numbers exceeds 3 times the smaller number by 4. So 3x plus 4 would give you the value of that larger number. Again, using x to define it, the smaller number. Now, the next part is really what's going to allow us to finally solve this. The sum of twice the larger number and 4 times the smaller number is 58. So let's take this in steps. The sum, so we're going to be adding something. The sum of twice the larger number. So if the larger number is defined as 3x plus 4, we have to double that. So let's put 2 times, open a parentheses, the larger number. There we go. So twice the larger number, twice the larger number defined as 3x plus 4, and 4 times the smaller number. So the smaller number is x, so that one's easy, plus 4x, 4 times the smaller number is 58. We have our answer. It could be tricky again because of the wording, and if you just try to break it up in steps and do something like this little table here, it can help guide your work. So when we try to match this, we'll see that J is a perfect match, the correct